Depending on the type of PBCS application you've built, light, standard, or enterprise, you may be able to take advantage of the ability to create multiple databases for your application. The terms database, plan type, and cube can all be used interchangeably. In a standard PBCS application, you can use up to 7 databases, 3 block storage cubes, and 4 aggregate storage cubes. We'll now take a look at the difference between these database types and discuss why using multiple databases may be desirable. As mentioned, there are 2 types of database available to use: block storage, or BSO, and aggregate storage, or ASO. Each database type provides its own advantages for specific activities. Block storage databases use dense and sparse dimension settings to take advantage of data sparsity to minimize the amount of physical memory and disk space required. In this context, sparsity means that blocks are only created to store data values when they are required. By minimizing the number of blocks that are created, the database can be made to remain responsive. Block storage databases provide a lot of functionality related to calculations. However, they have limitations when dealing with very large datasets. Aggregate storage databases are less powerful than block storage when it comes to calculations. However, they're better equipped for dealing with large datasets. ASO cubes don't store any aggregated values, but instead calculate them whenever they're required. They're very fast at preparing aggregate data from input data, as the name implies. ASO cubes can perform certain calculations, either by the aggregation of values through dimensional hierarchies or using dynamically calculated dimension members, though as mentioned, this is less robust than the calculation engine provided by block storage databases. Here we can see an overview of the main differences between block storage and aggregate storage databases. In block storage databases, data is stored in blocks with the aim of making the blocks of data as densely filled as possible and storing as few blocks as possible whilst still supporting the complete dataset. Storage options can be set for individual members, allowing some to be stored, others dynamically calculated, and so on, as required. Data entry can be done at any level in the hierarchy, dependent on the properties of the version member you're working with, allowing for both base-level data collection and top-down allocations. They utilize a powerful calculation engine which allows you to customize your application's behavior and manipulate data in very precise ways. The drawback to using block storage is that you can have no more than 20 dimensions in the database, with an optimum number in the region of 10 to 12 dimensions, and that the performance of the database will be highly dependent on good design practices. In aggregate storage databases, data is instead stored in table spaces, and storage options can be specified at the dimension level only, not the member level. This means the hierarchies in an aggregate storage database are somewhat less flexible. Data entry can only be done at base level, meaning that top-down allocations are not supported. Aggregate storage databases can only utilize very limited calculation capabilities and don't have the same level of flexibility as block storage ones. In terms of benefits, however, aggregate storage cubes are equipped to deal with much larger volumes of data as they're optimized for retrieval speed. They can also handle much larger numbers of dimensions with many more members. PBCS applications use block storage, BSO, S-base cubes by default. Aggregate storage, ASO cubes can be created as additional plan types to be used for reporting purposes. When deciding upon the database setup that you require, there are a number of questions to consider. Is there a powerful calculation requirement? If so, a block storage database will be required, as complex calculations are not possible with aggregate storage. Is a separate reporting cube required? If so, there will be an additional maintenance overhead, as certain settings will need to be applied to each database that is created. You should also consider if there is enough data to warrant a separate reporting cube. If your application is relatively small, you're unlikely to experience the benefits of such an approach. Finally, if you do decide that both block storage and aggregate storage databases are required, data transfer values will need to be set up using smart push functionality in order for the reporting cube to be populated with data.